So in this video, 5.1.2, we're going to continue with our work in section 5.1 of the textbook on verifying trig identities using the fundamental trig identities. So remember to keep your fundamental trig identities handy. So that's the identities that you see listed here on the right. We're going to use those to help us convert our identities from one case to the other. So let's take a look at this first example. We're trying to take 1 plus sine of theta over cosine of theta and turn it into secant of theta plus tangent of theta. So I notice, first of all, the left side kind of seems more complicated, so I'm going to start with the left side. And my goal, remember, is to convert it to the right side. I never want to assume these two sides are equal. I always want to start with one and eventually turn it into the other. So let's see. In the past, I've tried to put things into one fraction, but I notice that this has been separated and it's not all over one common denominator. So I'm thinking maybe I'll separate the two fractions and convert this to an equivalent form of 1 over cosine of theta plus sine of theta over cosine of theta. So I have to know that for fractions, if you have a sum in the numerator over a denominator like d, that it's equal to the sum of a over d plus b over d. So we need to be strong with our fraction skills in order to solve these problems quickly and efficiently. So I'm using that fraction skill to separate that, and now I keep my eye on my end goal, which is to get secant of theta and tangent of theta into my situation here. And I realize that 1 over cosine of theta is equal to secant of theta. So I'm going to replace that with secant of theta. I also see that sine of theta over cosine of theta is equal to tangent of theta. How convenient. So now I am at my end goal. I've successfully turned this into this, and I have verified the identity. It is as simple as that on occasion, and sometimes it's much more complicated. Let's look at the next example. So we have an example of two fractions being added equal to 2 secant of x. So we notice the left side is rather complicated. So we're going to start with the left side. And we're going to use one of the suggestions that was mentioned in the former video, in the first video for this section. And that recommendation was when you have two fractions, let's add them together by getting a like denominator. I realize that my like denominator is going to be the product of the two denominators that I already have. So my resulting denominator is going to be the following: 1 plus sine of x over times cosine of x. So I need to figure out how to turn each of these fractions into this denominator so that I can add the two fractions together. And of course, that means I'm going to multiply top and bottom of each of those fractions by a common thing. So I'm going to take the first fraction and I'm going to multiply top and bottom by cosine of x. That way I get that factor of cosine of x in the denominator of that fraction. So let's see, on the top I'm going to get cosine squared of x. The other fraction I'm going to convert by multiplying top and bottom by 1 plus sine of x, in order to get 1 plus sine of x in the denominator of that fraction. And I see that on the top I'm going to have a product of 1 plus sine of x times 1 plus sine of x, or 1 plus sine of x squared. Now I'm ready to add the two fractions together. But before I do that, I think I want to multiply out 1 plus sine of x squared. I'm going to multiply that out. So I'm going to work that out here. I remember that 1 plus sine of x squared, of course, is 1 plus sine of x times 1 plus sine of x. Using FOIL or any other strategy like generic rectangles, I'm going to get 1 plus sine of x plus sine of x plus sine squared of x. I'm getting my 4 terms. Of course, that simplifies to 1 plus 2 sine of x plus sine squared of x. So I've successfully represented and multiplied out that product. So this value here is equivalent to this value here. So now I'm going to take that and use that to help me simplify my fraction. So when I rewrite my fraction, I'm going to still have this cosine squared of x in the numerator plus this quantity instead of writing the quantity above. So 1 plus 2 sine of x plus sine squared of x, all over that weird common denominator of 1 plus sine of x cosine of x. Now, never forget what your goal is. So we've done all this work. It seems a lot more complicated, but never forget what our goal is. I'm going to go back up and peek at what my goal is. My goal is to convert the original of the statement to 2 secant of x. So I want to think about what secant of x is equal. It's equal to 1 over cosine. So that gets me intrigued. I like having cosine in the denominator, and if I remember my former expression here, it has a cosine in the denominator. So I like that there. That's promising. But I need to somehow clean up everything and get rid of everything else and make the top equal to 1. So I'm going to start with looking at the top and thinking about what identities I have. I see cosine squared and I see sine squared being added. I know that the sum of those for any angle will equal 1 by the Pythagorean identity. So I'm going to replace those two with 1. So then in my numerator, I'm going to have 1 plus 1 plus 2 sine of x. Or essentially, I'm going to have 2 plus 2 sine of x. I'm also liking that too. Remember what our goal is? To make it equal to 2 secant of x. So all these 2's make it promising as well. So the top is much more simpler now. 1 plus sine of x in the denominator still, and cosine of x. So I got to figure out how to get that 1 plus sine of x out of the denominator and clean up the top. Let's see here. How about we try factoring the top? Let's factor out that 2. 1 plus sine of x. Now I can cancel out that 1 plus sine of x in the denominator and be left with simply cosine of x in the denominator after factoring out the 2. This will cancel. I'm left with 2 over cosine of x, which we know by a simple reciprocal identity that 1 over cosine is equal to secant of x, so 2 over cosine is equal to 2 secant of x. I have arrived at my endpoint because I have accomplished my goal of getting the expression to equal 2 secant of x. So this involved quite a few steps. We had to factor, we had to find a product of binomials, but the end goal is always to not give up and to just continue trying to replace things with simpler things like we did with the Pythagorean identity. Let's take a look at the next example. One more example before you'll try some problems on your own. So our next example involves both sides have a fraction, and this one's going to be rather tricky, so you want to be careful with this one. This one is going to involve some intuitive and challenging things that you're going to want to keep in the back of your mind for future identities. So I'm going to start with the left. For no particular reason, they're both rather complicated. Okay, being the math person that I am, I'm really going to look at the right side and focus on where I'm trying to go. I'm trying to get the denominator to turn into sine x and the numerator to have 1 minus cosine of x. So I think about different things that I know about sine of x and cosine of x. I think about my fundamental identities that were over on my sheet here, and I see that I have quite a few that I know about sine and cosine. I have this one. I have that they're related to each other by tangent. I guess that's the only 3 that I have. So I also see the 1 here in the Pythagorean identity, and I think, how can I get Pythagorean identity to open up and appear before my very eyes? Well, we have some ideas here. Perhaps I want to get sine squared of x on top. Perhaps I want to create this to be 1 plus cosine squared of x. But in the end, you're actually going to want it to equal 1 minus cosine squared. Let's think about why. The reason why is if I convert this identity and I subtract cosine squared from both sides, I get sine squared of theta equal to 1 minus cosine squared of theta. If I get cosine squared of theta, I can replace it with sine squared of theta. And that would introduce the sine value in the denominator of my expression. So this is going to do it, because if you remember the difference of two squares, if I multiply this out on the top and the bottom, let's see, these two terms will cancel. I'm going to get cosine of x minus cosine of x. When I multiply the first two for FOIL, I'm going to get 1. And when I multiply the last two, I'm going to get minus cosine squared of x. This will simplify, because these two will cancel out. This will simplify to what I was looking for, 1 minus cosine squared of x. So we'll want to review some of those factors and special products that we worked with back in Algebra 2. So on the denominator, I'm going to have 1 minus cosine squared of x, but I'm going to quickly replace that with sine squared of x, because I know my Pythagorean identities. On the top, I'm not going to multiply it out because I like that 1 minus cosine of x. It's similar to my end goal. So I'm going to leave that as sine of x times 1 minus cosine of x. Now let's move some of this stuff out of the way so that we can see where we can head from here. I see a sine of x on top and bottom that I can cancel. So I'm going to cancel one of these and get 1 minus cosine of x over sine of x. I've arrived at my end goal and verified the trig identity. Now, this took a lot of Algebra 2, algebra factoring product techniques that we will definitely review in class. Let's give you a chance to try some of this using your checkpoint exercises. So give these next 4 problems a shot. The last two, number 6s and 7, will be a little bit more challenging, but see if you can repeat some of the things that I did. 7 is an example you haven't seen, so let's see if you can take it a step further. If not, we'll start class going over number 7, an example similar to number 7. Bring those checkpoint exercises into class tomorrow so we can go over them and answer any questions you may have.